So, when you hear the word blockchain, what comes to mind? For a lot of people, it's crypto prices, or maybe some dog meme, or that thing that uses a ton of energy, right? But if we strip all that away, blockchain is actually a very specific invention. It's a way for total strangers on the internet to agree on a shared history of events without having to trust a single company to run the whole show. And that brings up the single most important question you can ask about this technology. If we already have databases, why on earth do we need this? That's the exact question we're going to unpack right now. At the end of the day, it's all about a trade-off. A normal database, the kind that runs pretty much every app you use, it's built for speed and simplicity. An admin can jump in and make fixes, and one single organization is in control. A blockchain, though, it's for something totally different. It's for when you need records that anyone can verify, where there's no single owner, and the system itself is what we call credibly neutral. You're basically giving up some performance to get rid of the need for trust.
Okay, let's try an analogy. Picture a shared spreadsheet that keeps track of who owns what. Now, if a single bank or a company controls that spreadsheet, life is pretty simple. They're the referee. But what if you want a system with no referee at all? That is the fundamental problem that blockchain was designed to solve.
See, the moment you get rid of that central boss, you slam right into three really, really hard problems. First, who gets to add new entries to the spreadsheet? Second, how do you stop people from cheating the system? And third, and this is a big one, how do you get everybody to agree on what the true official record actually is? So how do we solve these problems? Well, the answer starts with the way the record itself is actually built. Let's dig into the mechanics of the chain and see how it creates a history that's incredibly difficult to secretly change. First thing you need to know about is the block. Just think of a block as a single page in our shared digital notebook. It's got a list of transactions, a timestamp of when it was created, and this is the absolutely crucial part, a reference to the page that came right before it. Okay, and here's the magic trick, the thing that links it all together. Each new block of transactions gets run through a special algorithm, and that spits out a unique digital fingerprint called a hash. Think of it like a one-of-a-kind serial number for that specific set of data. And for the next blocks to even be considered valid, it must include the fingerprint of the block that came just before it. That's what creates the secure interlocking chain. And that right there, that's the heart of the whole security model. If you try to go back and mess with a transaction in an old block, that block's digital fingerprint will totally change. That immediately breaks the link to the next block, which breaks its link to the one after that, and so on all the way down the line. The entire chain becomes invalid from that point on, making any tampering completely obvious. That's what tamper-evident really means. And this is a really important point, immutable doesn't mean it's literally impossible to change. A much better way to think about it is that the whole system is designed to make changing old records ridiculously expensive and difficult, either economically or computationally. It just raises the cost of cheating so high that it's just not worth it for anyone. All right, so we've got this chain that's super hard to tamper with. Great, but what happens in a network spread all over the world where, say, two different people might create a valid new block at almost the exact same time? How does the network decide which one becomes the official history? I mean, this is the whole ballgame, right? Without a boss to make the final call, how does a network of strangers who don't even know each other come to an agreement? The answer is something called consensus. And don't let the fancy word fool you. It's really just the set of rules and, this is the key, the economic incentives that push the entire network to agree on one single authoritative version of history. Now, the two big ways networks do this are called proof of work and proof of stake. And they both have the exact same goal: make dishonesty incredibly expensive. With proof of work, that's what Bitcoin uses, participants basically burn real-world energy to compete to solve a puzzle. To cheat, you'd have to outspend the entire rest of the network combined. With proof of stake, participants lock up their own money as collateral. If they try to cheat, poof, their money can be taken away. In both systems, being honest is simply the most rational economic choice. Okay, so we've got the nuts and bolts down. Now let's pull back and look at the big picture. What's the price we pay for this kind of trust, and what are the real-world problems it's actually good for? And that brings us to this classic idea called the blockchain trilemma. It's a great way to think about the challenges here. It basically says it's incredibly difficult for any network to be perfect at all three of these things at once: ironclad security, true decentralization, and super high speed or scalability. If you try to improve one, you usually have to sacrifice a bit of another. And that's exactly why so many different blockchains exist. They're all making different trade-offs. And another thing, that word decentralization, it's not just an on-off switch. It's way more nuanced than that. You have to think about at least 4 things. How many computers are validating the chain? How many different people are actually producing the blocks? How many different versions of the software are out there? And who gets to decide the rules for the future? So after all that, you're probably asking, what is this actually good for? Well, it really shines in situations where you need a shared, verifiable record without a single person in charge. Think about digital money that doesn't need a bank because the rules are out in the open for everyone to see. Or think about proving you own a digital item without needing some central company's database. Or creating a transparent audit trail for a supply chain where all the different companies involved don't really trust each other.
Look, the bottom line is you have to think of blockchain like a very specific tool in a giant toolbox. It's an amazing fit for low-trust environments where being able to publicly verify everything is critical. But it's a terrible, terrible fit for something like a company's internal high-speed database, where having a central admin in charge is actually a feature, not a bug.
There's this great analogy that I think just nails it. The whole system is slower and way less efficient than just having one trusted person in charge of a notebook. But its real power, its superpower, is that it keeps working correctly even if that trusted person just vanishes, or worse, tries to cheat. And really, that's the big idea I want to leave you with. This technology isn't some kind of magic wand. It's a new tool for people to coordinate with each other. So just ask yourself this. What in your world depends on a central referee, and what would suddenly become possible if you didn't have to trust them anymore?